All right, so lesson number 5 is on modeling and equation solving. So whenever you see modeling in a math class, what it means is story problems. So it's creating a model in order to solve a problem. So in order to do this, we often need to draw a picture or assign variables that make sense. So maybe you talk about A for area, or you talk about P for perimeter, or B for base, right? You're in pre-calc now. So when I say the word story problems, it should not cause fear in your hearts. You should be able to do this. Does it still cause fear in your heart?
Yes.
A little bit?
Yes.
You'll be okay. You can do this. All right, so Katie is deciding between 2 jobs at the mall. Oh, Katie. She plans on working 30 hours a month. That's not too bad. One job pays her $300 plus 5% of her total sales, while the other pays her $200 plus 8% of her total sales. How much would Katie need to sell in order to make the second job more attractive than the first job? All right, so sometimes there's extra information in the problem. So sometimes you might do something like this one that says that she's working 30 hours a month, but it doesn't give a monthly, like an hourly rate or anything like that. So we don't actually need to use the fact that she's working 30 hours a month. Okay, what we do need to decide is what to make our variable. So what should we make X?
We're not used to sell.
Yeah, so X is the amount of her sales. So I don't know if you know how commission works, right? Maybe she sells $10,000 worth of clothes. She's not making $10,000 off of those clothes, right? She's making a certain percentage off the clothes. Okay, so we're going to let X equal the total amount of sales, right? And we should always define our variable. All right, so one of the jobs is paying her $300 plus 5% of her sales, and the other job is paying her $200 plus 8% of her sales. And we want to know what one makes the second job better than the first. Okay, so we could say the second one is bigger, like greater than or equal to. It doesn't matter. I'm just going to do greater, well, less than or equal to. So first one is less than or equal to the second one. And we're going to solve it out. And it's okay if you just did equals and then you think about, oh, wait, this one is the one that's less, but I want to sell more, right? You can do that if you just do equals. All right, so subtract the 200. I get 100 is less than or equal to 0.03x. So when you divide that out, you get the lovely $3,333.33. I could have made it much nicer, couldn't I? Is less than or equal to X. So what does that tell us? That she needs to make at least $3,333.33 worth of sales, right?
So that's, man, that sucks. X has to be, can we just leave it as X has to be greater than or equal to that, or do we have to actually write it at least?
Usually I have you write a little statement. It doesn't have to be a full sentence, just something. All right, so next one says how much of a 12% acid solution should be mixed with a 20% acid solution to get 20 liters of a 15% acid solution. So if you were in my Algebra 2 class last year, we did this in Algebra 2. I always told you to draw little jars. Or you can draw squares if you are artistically challenged. And inside of the jars, we always put percentages. And below the jars, we always put the amounts. So when you say how much of a 12% acid solution, that means we're going to put 0.12 inside the first jar, 12% acid. Should be mixed with a 20%, so 0.20, to get a 15% acid solution. Okay, so percentages are never going to add up, right? You're not going to take a 12% acid solution and add it to a 20% acid solution and get a 32% acid solution. You understand why that's how it is? Right, you're going to dilute the 20% by adding the 12%, right? So it's going to be somewhere between the 12 and the 20. But the amounts will add up. Okay, so if I had like 10 liters of the first one and I added it to 20 liters of the second one, I'm going to get 30 liters of the mixture, right? So the amounts along the bottom, those add. So it says how much of the 12% acid solution? So that's going to be our X. So we're going to say let X equal the amount of 12% solution. So we're going to put X there. And we know we want to get a total of 20. So under the third jar, we're going to put 20. So do you guys remember what we put under the second jar? And you know? Ah, Ian spoke louder. I heard you say it quietly though. So yes, if I take like 3 liters of the first one, then I need 17 liters to create the 20 liters, right? If I take 5, I need 15 to create 20. So those numbers all add up on the bottom. So when you create our equation, it's talking about the amount of acid in each of those. So the amount of acid is 12% times the amount we have, plus 20% times 20 minus x equals 15% times 20. And we just solve the equation. So we have 0.12x plus 1/5 of 20, so 4. See, fractions are a friend. See how I did that? I did fractions instead. Minus 0.20x, all right, and then 3. And we continue to solve. Oops, -1. So we should get x equals 12.5. Oops, 12.5 liters. All right, now a lot of the times this will say how many liters of this plus how many liters of this equals blah, blah, blah. So this is one where you definitely have to write the little last statement. So you need to say 12.5 liters of 12%, and then you could even help me out with the other one. How much are you going to have for the 20% then, if you have 12.5 for the first one? 7.5, right? So 7.5 liters for the other one. All right, all coming back to you. You remember this? No, oh no. Make me cry, guys. Yes.
I think the 0.12x going to x is 10.10.
What did I do?
0.12x minus 0.2.
No, it would be negative 0.08. Yeah. Yeah, negative 0.08. All right. Next up. I get bonus points if they correct me. All right, number 3. So one positive number is 2 times another positive number. The sum of the two numbers is 310. Find the two numbers. So you could make your numbers x and y if you want to do 2 variables. Or you can just say, okay, well, I'm going to let x equal my first number. And then since I know the other one's 2 times the other one, 2x is going to be the second number. Right? So you don't have to use x and y. You could just do this all in one variable. So then it says the sum of the two numbers, x plus 2x, equals 310. So this is not a hard problem. The thing that's tricky, though, is that we get 3x is equal to 210, or 310, sorry. And 310 is not divisible by 3. But is that okay? Can x be 310 over 3, which is approximately, well, it's not approximately, I'll do the repeating sign. It's 103.3 repeating. Can it be that number? Sure. I didn't say that it had to be an integer. If I had said one positive integer is 2 times another positive integer, then it could be that, right? But I didn't say that. I said a number, and it's a number. So we're good.
I mean, there was 206 points.
Yep. So your second number is going to equal 620 over 3, which is 206.6 repeating. So that's okay. You can have numbers that look like that. All right, the ones you guys didn't like in Algebra 2 were the frame ones. You guys remember frame ones? So this is frame 1. So it says a large painting for the IMA, so this is a really big painting actually, is 3 feet longer than it is wide. Okay, so let's kind of draw a little rectangle. And we're going to call the width W, and we'll call the length W plus 3, right? So we're letting W equal the width. And it says if the wooden frame is 12 inches thick and the same thickness all the way around, the area of the frame and the picture is 208 feet cubed. So when I started doing this problem, I started writing it out, and I was like, okay, I'm going to have 12 inches here, 12 inches here, 12 inches here, and so on. So 12 inches all the way around. So this is pre-calc now. It's different than Algebra 2. You have to be very, very careful, and you have to pay attention to your units. So what is wrong with this? Yeah, the 3 was in feet, right? And the 12 was in inches. But notice how at the end we want 208 square feet. So let's go ahead and change every single thing to feet. Can we do that? So instead of having 12, what should I really write? 1, right? So I'm going to say 12 inches, which is equal to 1 foot. So inches are the double mark, foot is 1 little tick mark. So all of these numbers, I'm really just going to have a 1 there. So when I talk about the whole length and the whole width of the frame, right, it's not just W plus 3 and W. I've now added 1 foot on each side. Okay, so instead of having W plus 3, I'm going to have W plus 5 because I add 1 on the right and I add 1 on the left. Right, instead of having W, I'm going to have W plus 2 because I add 1 on the top and 1 on the bottom. So the area of the whole frame, like with the picture inside, is going to be W plus 5 times W plus 2, and that has to equal 208. So this one can be solved without a calculator. I'll do a couple in a second that we'll use a calculator. So we're going to FOIL things out. So we have W squared plus the outer is 2W and the inner terms make 5W. So we get 7W plus 10 equals 208. Okay, and we're going to factor. So we get W plus 5 and W plus 2. Oh, wait, why am I factoring? Thank you, Ian. I'll give you a point.
Never go.
All right, write your name on one of the boards so I remember. All right, so minus 208. So if I subtract 208, what do I get? 198. And now I need to factor. I was already a step ahead of myself. Now 198, if you divide it by 2, it's 99. So if you need to do like a little factor tree, so you can see this, 198 breaks into 2 and 99, but 99 breaks into 9 and 11. So think about different combinations of these numbers. What do I need for my other numbers? So do I need like 9 and 22? Do I need 3 and something else? Do I need 33 and 6? Do you guys see what I'm doing? I'm taking different combinations of the numbers. What do we need? How about the 2 3s together with the 2? What's that make?
18.
18 and 11. So we're going to have minus 11 and plus 18. Now, if you can't do that, if you have trouble like thinking about all the different factors, then just use the quadratic formula. It's almost as fast when you have big numbers like that and you're trying to think of the factors. So we end up getting W equals 11 and W equals negative 18. Which one's out? Negative 18. We can't have a width of negative 18 feet, right? So the width is going to be 11 feet. What does that make the length?
14.
14, correct. So our dimensions are going to be 11 feet by 14 feet. Whoops, I did inches there. Feet. All right, and that's our answer. Still okay? Not too panicky, Katie?
I was just confused on where you got like the W plus 5 and the W plus 2.
Because this original length was W plus 3 right here, the part I'm drawing in green, and then I'm adding this side and this side to it, and they were both 1. So if you had W plus 3 and you add 1 on the right and 1 on the left, W plus 5, right? Make sense? And then this one was W, and if I add 1 here and here, right, W plus 2. Make sense?
Yep.
All right. Next problem. I really messed up this problem. I always try to like proof my problems before I print, you know, all of these notes for you. And this one I did not proof. So suppose a car depreciates linearly. So do you guys know, like, as soon as you drive a car off a lot, so as soon as you buy a car and you pull out of that lot, it's usually like around half its value, which is kind of crazy, right? Because it's like, I just bought it. How can I not take it right back? But it's around half the value because now it's a used car. It's kind of crazy. But we're supposing that it depreciates linearly. So basically, for X number of years, it's going to be depreciating a certain amount each year. So it says when it was first bought in 2012, the car cost, I want you to change that from $20,000 to $30,000. And then 3 years later, the car is valued at, that should be $13,000. I got a little crazy with my zeros. It did not go up in value. Is it a classic car?
Okay, that was
Okay. Yeah, and I should have put a little dollar sign too.
Yeah.
All right, so it says find the price of the car in 2021. All right, so we need to come up with this linear equation. We need to come up with a line. So when we're trying to come up with a line, we first need to find slope. And in order to find slope, we need a couple points, right? Well, we do have points. What we're going to do is we're going to let x equal the number of years past 2012. So the first point is at 0 years. So at time 0 in 2012, what was it worth? Yeah? It was worth 30,000, right? That's what I told you to change it to. And then later on, 3 years later, it was worth 13,000. All right, those are 2 points that we can use to come up with the equation of the line. So we find m. So we do 13,000 minus 30,000 all over 3 minus 0. So we get negative 17,000 over 3. That's my slope. So if I was plugging things into y equals mx plus b, I could use any point to plug in for x and y, or I can recognize that I already have b. What is b?
0,30,000.
Yeah, it's 0,30,000. Think about the point. Like if you were graphing that, you would go over 0 up 30,000. That's the y-intercept.
The answer if you divide, so saying is 56, 5,666 or 67 to the right word.
I don't know what you're talking about.
Should we round it?
Like the negative 17,000 over 3? Or just leave it like that?
Okay.
All right, so how do we find the price of the car in 2021? So we have the linear equation. What do we plug in for x?
Well, years since 2012. So
Yeah, Ariana? 9, exactly. So we're going to plug in 9. So in 2021, x is equal to 9. So we say y equals negative 17,000 over 3 times 9 plus 30,000. Oh, man. Still bad. Still bad even when I change the numbers. This car is negative. It's negative 21,000. Dang it. I got a what? It shouldn't drop that much. So the problem is I should make this higher, right? That's my problem with the problem. So I should make it like 23,000. That would help me, right? What if I made it 23,000? Does that make it, so then that would be 17? I wonder how to fix the problem! It was a negative number, that's the problem. Guys, shh, it's fine. Alright, so yes, we have to edit both things, I guess. So we should have made this, instead of 13,000, I should make it, let's make it 23,000. That will work. So you're just going to adjust this number. This is going to become, instead of 17, it will become negative 7,000. Okay, so, and then it works out okay. We're good. So then when we do that, we get negative 21,000 plus 30,000. So we get 9,000. So it would be $9,000 then. So I had to depreciate too much. So 9,000. Otherwise, there's a negative.
So close.
All right. So when will the car be valued at $1,000? So obviously, it's guys. Obviously, it's after 2021, right? So we want to find when it's equal to $1,000. So what we do now is we plug in 1,000 for the y value, and we solve for the x. All right. So we're going to take our 1,000. And we're going to subtract over the 30,000. So we get negative 29,000. And then we're going to multiply by the reciprocal. So we're going to multiply by negative 3 over 7,000. And that will go away, right? All right, so we get x equals 12.429 years. Okay, so that's how many years? So it's that number of years past 2012. So about where?
2024.
Yeah, in the year 2024. So somewhere in that year, it's going to be at that price.
Could you also have just multiplied by 3 on both sides and divided by 2?
Yeah. All right, number 6. So it says a gift shop in Zionsville is creating boxes to be decorated and sold in their stores. So they want the total volume to be 484 cubic inches. Squares are to be cut out of a 20-inch by 25-inch piece of cardboard. So I did this little experiment for you last year, so you could see exactly what I'm talking about. Can you visualize it in your head now? You're folding up the flaps, you're creating a box. Okay, so these little pieces are going to be gone, and you're going to fold up that flat, and it's going to be a very shallow box, kind of like a shirt box.
Yeah.
So that's what that one's going to look like. Okay, it says a lid will be made in a separate process, so we call this an open top box. So what size of squares should be cut from the cardboard? So these little squares are going to be X by X. Okay, and we knew originally that it was 20 inches and 25 inches. So what I need to do is I need to find this distance that I'm drawing in blue right here. So instead of being 25, what is it going to be?
25 minus 2x.
Yeah, exactly. You subtract X from the top and the bottom. You're cutting it out. All right, and then what about this green line? What's it going to be?
20 minus 2x.
20 minus 2X. Same idea. So when you do this, you create, like I said, like a little shirt box almost. Okay, and one of the sides is the 25 minus 2X, and one of the sides is the 20 minus 2X, and then the height of the box is what? It is X, correct, Will? Because you're folding up that flap, and that's now the height of the box. Okay, so we create our equation. We say volume, well, that's length times width times height. So in our case, it's 25 minus 2X times 20 minus 2X times X. And we want that volume to be a certain number. We want it to be 484. Are we all in inches? Everything's in inches. We're good. So we get 484. All right, so this is going to be a lot. We're going to have to multiply out. All right? That would be a lot to do by hand. So I'm going to let you use your calculator. So what we're going to do is we're going to plug in something for y1 and y2. So over here, I'm going to have y1, and over here, I'm going to have y2. Whoops, not y squared, y2. On the calculator. Okay, so pull up, get a calculator out. If you need one, there's one on the desk. There's two on my desk. Yep, and we're going to find the intersection point. Oops. So 484 for the first one. And then the second one, just keep your parentheses and everything. So parentheses, 25 minus 2x. Parentheses, 20 minus 2x. And then x. Yep, and you're going to hit graph. And you probably still have that standard window that we usually use, the negative 10 to 10. And let's talk about why we don't see much of anything really on this standard negative 10 to 10. Okay, so in that first one, y1, what does y equals 484 look like? It's a horizontal line, right? Where does it go through? It's like way up high. It goes through 484. So for our window, so hit window, what should we go to for the y's? Not negative, positive 500, right? For the y min start at 0 and the y max start at 500. Because we don't care about a negative volume. That's not going to work. So 0 to 500. All right, how about the x min and x max? X is what in this problem? What is x representing?
The squares.
Yeah, the size of those squares that you're cutting out. So can it be negative? No. So we're going to start at 0. Oops, sorry, y min is 0. Y max. Can it be like 100 inches that we're cutting out?
No.
What's kind of the biggest thing that we could possibly even cut out? So if we have a 20-inch side, how much should I cut out from the left and from the right? What would be too much?
10.
10 would be too much, right? So we're just going to go up to 10.
Oh, yeah.
And we're going to hit graph, and we're going to cross our fingers and hope that we have a good window. So we have that one up there. And we have that one right there. And it's crossing twice, but I still can't see it very well, so I'm going to do a window. And instead of going to 500, I'm going to go up even further. I'm going to go up to 700, just so it's a little bit nicer. All right, so we have that. So what I'm trying to find is where y1 intersects y2. I'm trying to find the intersection points. So we need to do that second trace intersect thing. So we're going to do second trace.
What if it went to 1,000?
Intersect, you can do that, that's fine.
And then where do you?
All right, so second trace, and you're going to go down to intersect. You guys see what I'm doing? So I hit enter. Now when it says first curve, this is not like the left bound, right bound thing. You don't need on the left of what you're trying to find or anything. What you need to do is, along this first curve, which is y1, right, the horizontal line, I want to go exactly where I think that intersection point is. So am I on top of it? Yep, I'm going to hit enter. And then it says second curve. Now when you're moving to the right and left, notice how you're along that other curve. You're along y2. So go exactly where you think that intersection point is. Hit enter. And when it says guess, hit enter again. So our first intersection point is 1.222. We'll round to 3 decimal places. So 1.222 inches.
That's.
All right. Now, do you see that there is actually another one? There is another intersection point. So we should find that. We need to find this intersection point that's over here. So we're going to do second, trace, intersect. So option 5.
I may have done this out of order.
We're going to go over. It's fine. You can do the other one. So we hit enter. Second curve. We're on top of it. Hit enter. Hit enter again. What do we get?
6.87.
6.871. 3 decimals.
So.
Can both of those work?
Yeah.
Sure. You can cut out 6.87 inches from both sides. There's still enough room for that. Tell me the difference in the shapes of the boxes. What does the first box look like when I cut out 1.222? What's the height like? The height's kind of small. It's like one of those shirt boxes, right? Do you guys understand that? You're folding it up. It's pretty wide both directions. It'd be good for a shirt. All right, now what about the other one? When I cut out 6.871, I'm cutting out a really big thing and I'm folding it up. It still has that volume of 484. But what's different about the box?
It changes the height.
It changes the height, right? So this box would be a box, I don't have one in this room, but it would be like a taller box, right? Like a shoe box kind of on its side. Does that make sense? It'd be a little bit higher. Yeah, Katie?
I printed out like the 25, you did 25 minutes to X, and 20 minutes to X, where did you get that?
Where did I get the 2? From the same idea from the last one. So like you're cutting out X from the first, from the top, and X from the bottom.
So is that just our
Yeah,
answer?
but when, like, 2.
Because you have you had 25 originally, and you cut out X and another X. So X plus X is 2X.
Is that our answer right there?
Those are our 2 answers. So both of those are answers. So what size of square could be made? This one or this one? They would both create it.
Well, wouldn't that change the height, which would not do the right volume, or would they both?
They would both give the same volume. Yep, they both give that 484. All right, a couple more. I know this is a long section. All right. So I'm currently in the process of trying to get concrete for a patio, and it is a very annoying process because you have to measure precisely how much concrete you need. You need to talk to all the people and get estimates. They're never really totally sure, like, they'll never really tell you an exact price. They all have to come out for quotes. And then they all tell you that it's like, they're like, oh yeah, it's like $13 per square foot. And I'm like, oh, I thought it was going to be like $5 per square foot. Like I put in this problem. It's not $5 per square foot. It's very expensive. Yes, it is very annoying. So this says a reflecting pool that is 200 feet long by 30 feet wide. Will be surrounded by an X foot wide and a 2-inch thick concrete sidewalk. So we're going to put this sidewalk around this reflecting pool. You guys know, like the reflecting pool, what that looks like. Like think of DC, like a really long pool.
Oh, okay. Monument.
Yeah. University of Indianapolis has one on their campus too. I just went down there recently. All right, so it's going to be an X foot wide. So it's X feet all the way around. So what happens is this distance around is going to be 200 plus X, so 200 plus 2X, right? And this other one is going to be 30 plus X, so 30 plus 2X. And we want this concrete to have a thickness to it, so it's going to have a volume. Okay, so there's a lot of steps to this. I kind of took up all my space on my drawing. I probably shouldn't have done that. Oops. So I can do magical things. Oh man, maybe I can't do magical things. Let me try this. I can do magical things and I can make things smaller. I wonder if I can do it all together. I know. I can't figure it out. Alright, whatever. So if I need more room, I'll just write down here. Alright, so here we go. So we want to find out the volume of the concrete. So first what I need to do is I need to find out the area of this portion that I'm shading in green. So just the part that's around, the area of the sidewalk, right? So my area would be, well, I'd have that outside portion, the 30 plus 2x, times my 200 plus 2x, but I have to subtract out the pool. I'm not going to put concrete inside the pool.
Aww.
So I'm going to subtract out the area of the pool.
So that's minus
What is 30 times 200?
60,000. 6,000.
Uh-huh. All right, so if I FOIL this out, I get 6,000 plus 60x plus 400x, so I get 600, not 640, other way, 460x plus 4x squared, but then I have minus 6,000, so that was kind of nice because the 6,000s go away. So that's my area, so I get 460x plus 4x squared. So what is the volume then? Ah, yes. So she says 1/6. Do you see where we're getting the 1/6 from?
Because you have 2 inches.
It's 2 inches, which is 2 out of 12, or 1/6 of a foot.
Oh.
So you're now multiply by the height of this, which is 1/6. Well, what is the cost? So this is all in square in cubic feet, right? And what's the cost per cubic feet?
$5.
$5. So for every cubic feet that you have, you multiply by $5. So what we do is we have 5 times 1/6 times 460x plus 4x squared. And we want our cost to be less than 2,000. So let's just find where it's equal to 2,000. So let's do 5/6 times 460x plus 4x squared. We want it to be equal to 2,000.
Where did you get the 5?
Because the cost was $5 per square foot,
Oh, okay.
or cubic foot, sorry. All right, so I will let you use your calculator again. You can plug in one for Y1, one for Y2, or you could even get fancy, and if you don't want to do the intersection method, and you wanted to find the 0, you could subtract the 2,000 over, right, and set it equal to 0. So let's say we try that method.
That's
Oops. It does not like when I hit the divide button.
So
Jeez.
y equal 2,000 does it equal 5/6 times 4? Is that how it works?
Yeah. All right, so you guys will need to adjust your window. Are you guys finding that? So someone find me a good window.
Oh, I just.
All right, so it looks pretty good, the window that I had before. But whenever you do the intersection method, you actually need your window to go less than, like below the x-axis. So I'm going to do y min is negative 200. So when I hit graph, I can get below the x-axis as well. So do you guys see where it's crossing? Okay, we're trying to find that point. So I'm going to do second trace intersect.
What's our max?
Or not intersect, sorry, second trace 0.
What's our max?
I just did like negative 200 to 700. All right, so left bound. Left bound means be below, in this case, because it's an increasing function, so it's on the left side. So right here. Right bound means get on the right of what you want, so hit enter. Guess goes exactly where you think it is, hit enter. The 0 is 5. So if you had done this all by hand, you would get x equals 5.
How do you know when you can use the intercept? Like the.
When you can use the calculator, when you can't? When you have a non-calculator section, you can't use it. When you have a calculator section, you can.
You don't need to grab it, you can put it in.
So our answer is X.
What did you use for, like your YMAX?
YMAX I used 700, it doesn't matter.
700?
Yeah.
You go to window and then make sure.
I'm going to pause real quick. Alright, so this last one says that the product of 3 consecutive even integers is equal to 168 more than 180 times the middle number. So write an equation to find the numbers and use a graphing calculator to find the solution. Okay, so if you have the product of 3 consecutive even integers, when you talk about that first number, we're going to call it x. The second one, the next even number would be x plus 2 because you have to skip over that odd number between it. And then the third number ends up being x plus 4. So we write the product of those 3 numbers is equal to 168 more than 180 times the middle number. Okay, does that make sense? So that's our equation. So x times x plus 2 times x plus 4 equals 168 plus 18 times x plus 2. All right, and then I said you can use a graphing calculator to find the solution. So what I would do is, without trying to simplify at all, because a lot of simple mistakes are made when you try to like subtract things over and so on, is I would just plug in for y1 and y2 and find the intersection. Yeah.
Where is 18 from?
Oh, 180, that's right. You got me. Should be 180 times x plus 2. I just read it wrong. So Christian, write your name on one of the boards so I remember. All right, so that's y2. I'm just full of them today, man. I just need a nap. That back to school night must have taken it out of me. All right. Oh gosh, I hate it when this calculator does this. All right, so go ahead and put in, I'm going to pause. All right, so we put in both of those things for y1 and y2, and when we hit graph, you get a cubic function, right, which is the first one, intersecting a line. Okay, and it's hard to tell, the line looks very, very vertical. It's not vertical, but its slope is 180, so that's why it's so steep. All right, so you need to find that intersection point. So it looks like this window's fine, the negative 10 to 10. So I'm going to do second trace intersect, so number 5, and I'm going to trace along the first curve to where I think it's actually intersecting, and I hit enter, and then I trace along the second until I'm on the spot where I think it's intersecting. Where is it? I don't know where mine is. I can't find it. All right. It is kind of hard to see. Yeah, it's kind of in the same spot. So go ahead and hit enter. Like, you can't see it because the window is too big. It's bouncing from, do you guys see the y equals -8? And then you see how it goes from y equals 30 something. So it's bouncing across those. So let's just get as close as possible. I know it's probably like 4. It looks like it's at a height of 4 or something, but we'll just do the 31. And then guess, go where do you think it is? Enter again. There's only one intersection.
Oh, there's.
All right, so we should get negative 2.917 and then 2 point, okay, we've clearly done something wrong here. So do you guys have the same graph?
I got 191.
Hang on. All right, because this is not an integer, right? So we have something wrong. So did I put something into my calculator wrong? So x times x plus 2 times x plus 4, and we said 168 more than 180 times the middle number. So we have that. All right, let's adjust the window then. Maybe there are 2 intersection points. We just can't see the other one. So let's go to a y max of, let's do like 300. Because that answer can't be right, right? We can't have x equals a negative number because it's supposed to be an integer.
So just do that.
So let's adjust our window. Let's try to figure it out.
300 still goes too high.
Okay, so let me play around with it. So see, even I have a hard time finding windows sometimes. Windows can be frustrating. Okay, still not good. So I'm going to go smaller. Anybody find a good one yet?
Oh my god, I went up to a y-max of 100, of 1,000, and it still goes over it.
Well, that can't work, right?
I'm literally going to try a 5,000.
So maybe I have something wrong.
I'm going to try a 5, or y max is 5,000.
It doesn't do it at 9,000.
Okay.
I have a better idea.
So maybe I just have something wrong with the problem. I don't know. All right. So it was just a window issue. So we can get the right window. Let's make the x values go up to 30. And let's make the y max. Because if you think about it, like you are taking 3 numbers multiplied by each other, it's going to be pretty big. Like even if the numbers were just 10, 10 times 10 times 10 is going to be 1,000, right? So let's go up really high. Let's go to 10,000. All right, and now when we hit graph,
It doesn't even intersect the 30,000.
when we hit that though, do you see it? There we are. All right, so now we're going to find the intersection point. So we're going to do second trace, intersect. First curve, second curve, guess. And it says x equals 12. So in this case, I think it would have been easier if we didn't use the calculator because it took so long to use the window, but the answer should be x equals 12. So if you just multiplied it all out, got everything on one side and so on, it might have been easier. All right, yes. Where do you put the first curve?
X equals